So here's some help with section 6.5 about double angle identities. On question number 2I. Now this is really a wonderful question. First of all, I can rewrite it by putting everything equal to 0. And what's tipping me off is I see a cosine squared. So anytime that I see a cosine squared, I'm probably going to need to do some sort of substitution. So I'm going to write this as 2 cosine squared 2x plus cosine 4x minus 2 equals 0. So it's starting to look like a quadratic. But there's a bit of a problem with this question. And the problem is that inside the first one we have 2x. Inside the second one we've got 4x. These don't quite match up. We need them both to be the same angle. So let me just try to write this using 2 times 2x. So 4 is 2 times 2x. So now maybe I can use one of the formulas to break this down. So my double angle formulas for cosine are cosine 2x is cosine squared minus sine squared, or 2 cos squared minus 1, or 1 minus 2 sine squared. Now because I already have a cosine squared, I'm going to change this one here to something that uses cosine squared as well, so that I don't mix up my cosines and sines. So let me choose this second one here. And then instead of theta, in this case, I have 2x. So I can change this one by writing it as 2 cosine squared 2x minus 1. So now I've got like terms. I've got 2 cosine squared 2x and 2 cosine squared 2x, which is 4 cosine squared 2x. 4 of those terms. And then minus 1 and minus 2 is minus 3. Now I'm just going to solve for cosine 2x, cosine squared. So first I'll move the 3 over to the other side. Giving me 4 cosine squared 2x equals 3. And then I'll divide both sides by 4. So then I get cosine squared 2x is 3/4. And now in order to solve for cosine 2x, I can square root both sides. Just to make sure to take both the positive and the negative roots when I do that. So then I get cosine of 2x is positive negative root 3 over 4. And I can also put those roots onto the top and the bottom. So root 3 over root 4, or root 3 over 2. And how much better could that be? That's a special angle. So now I'm just going to do a little substitution here. I'll let 2x be angle A. So this is much easier to solve. Cosine A is root 3 over 2, or negative root 3 over 2. So let's see. That means cosine is x over r. So x is the long side of a 1, 2, 3 triangle, or a 30-degree triangle. So let's see, that's here. X is long. It's adjacent over hypotenuse. All students take calculus. There's also a possible answer in quadrant 4. 2 places where cosine can be positive. Either 30 degrees, pi over 6, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6. And then where is cosine equal to negative 3 pi over 2? That's in quadrant 2 and quadrant 3. Here the x-coordinate is negative root 3. So that would be 1, 2, 3, 4, 5 pi over 6. 4, 6, 7 pi over 6. And that's what angle A equals. So now, because I let 2x equal A, I can put 2x back instead of A. So I'm going to say 2x is pi over 6, or 2x is 11 pi over 6, or 5 pi over 6, or 7 pi over 6. And to solve for x, I just divide both sides by 2. Dividing by 2 is the same thing as multiplying by a half, giving me pi over 12. So I just take all my answers and multiply them by a half. So that would give me 11 pi over 12, 5 pi over 12, or 7 pi over 12. I'm just taking all my answers and making them half as big. And that should be all the answers. Oh, nope, that's just 0 to pi. Let's see, what's the restrictions on this question? Solve from 0 to 2 pi. So I only got the answers from 0 to pi, halfway around the circle. Because when I have cosine 2x, then I can actually fit 2 waves from 0 to 2 pi. So I found out when is this equal to positive root 3 over 2, and I got 2 answers. And I found out when is it equal to negative root 3 over 2, and I got 2 answers. Now I've got to add the period to get the next set of 2 answers, both for the top and the bottom. So in this case, the period is 2 pi over b, and b is whatever's in front of the angle right here, 2. So this is compressed 2 times, so the period is half as big. So in order to get the next answers, I just have to take these ones and add the period. So I'm going to add pi to each of these answers, which doesn't work very well because I've got a denominator of 12. So I'm going to have to make a common denominator. 1 pi is the same as 12 over 12 pi. I'm going to add 12 over 12 to each of the answers. And that'll give me my next set. So pi over 12 plus 12 over 12 is 13 pi over 12. That's this one right here. Just pi away from the first answer. So adding 12 to the next one, 23 pi over 12 gives me this answer right here, pi away from this one. Now I'll use my 5 pi over 12, add 12 gives me 17 pi over 12 for this answer right here. And 7 plus 12 is 19 pi over 12 for the final answer right here. So I have 1, 2, 3, 4, 5, 6, 7, 8 answers from 0 to 2 pi.